Hi, this is Cliff from Redwood Tutoring. I'd like to talk to you about cube roots. Now, before I actually get into anything, what I want to do is just remind you guys of some common cube roots. See if you could think of them before I actually put them up on the board. Well, 1 cubed is equal to 1, 2 cubed is equal to 8, 3 cubed is equal to 27, 4 cubed is equal to 64, and 5 cubed is equal to 125. Now I think we're ready for a definition. Let me go ahead and put it over here on this side of the board. Let's suppose that I have some number, r. If it turns out that r cubed is equal to a, then we say that r is a cube root of a. So for instance, since 2 cubed is equal to 8, this means that 2 is a cube root of 8. Now, what I want to do is set up a table, and in my table, I'm going to have, on the one hand, a bunch of numbers, and then in the other column, I'm going to have the cube roots for those numbers. Leave some space if you're taking notes over here and over here. So if I have the number 8, we already determined that the cube root of 8 is 2, because 2 cubed is equal to 8. How about the number 64? Well, you ask yourself, what number cubed equals 64? Well, 4 cubed equals 64. 4 cubed equals 64. So 4 is the cube root of 64. Now, how about the number 125? What number cubed is 125? Well, 5. 5 cubed is 125. What about the number negative 27? Is there any number cubed that gives me negative 27? Well, as it turns out, there is. Negative 3 will do the trick. Negative 3 cubed, negative 3 times negative 3 times negative 3 will give me negative 27. And negative 64, for instance, well, 64, the cube root is 4. Negative 64, the cube root is negative 4, because negative 4 cubed equals negative 64. Now, over here on this part of the board, I want to write the notation that we're going to be using. We said that the cube root of 8 is 2. Here's the way that we write it. The cube root of 8 equals 2. Notice how this has a cube, and it's right in the little crevice here, right above the crevice. This indicates that it's a cube root rather than a square root. So here I could say the cube root of 64 equals 4. The cube root of 125 equals 5. And then here I'm going to have the cube root of negative 27 equals negative 3. I'm going to draw a little bit of a barrier here to separate these. And then here I'm going to have the cube root of negative 64 is negative 4. Now some of you might be thinking, well, wait a minute. I have a negative underneath the radical. I thought that I wasn't supposed to have any negatives underneath radicals. Well, as it turns out, if instead of being a cube root, this was a square root, then yes, you cannot have a negative underneath the radical if you want a real number. So let me make a note of this. Note, if I had, for instance, the square root of negative 64, Well, now I have a negative under a square root. This is not a real number. Because I can't take any real number and square it to get negative 64. But the cube root of negative 64 is fine. The cube root of negative 64 is negative 4. Because as we saw over here, negative 4 cubed is equal to negative 64. So the bottom line is that when you have a negative underneath a square root, it's not a real number. But a negative under the cube root is fine. In fact, there's a rule that I think you guys will, it'll be helpful for you to remember. If I have the cube root of negative a, then I could just bring the negative on the outside. The cube root of negative a is equal to negative cube root of a. I could just bring that negative onto the outside. Now let me go ahead and just do a couple of problems. Let's suppose that I want to simplify the cube root of negative 216, the cube root of negative 216. Well, as we just talked about, since this is a cube root, the negative could come onto the outside. So this could be rewritten as negative cube root of 216. Now, when you're writing this, make sure that you keep writing the cube root to emphasize that it's a cube root that you're dealing with rather than just a square root. Now here's what I'm going to do with 216. I'd like to take some space over here to break this down into its prime factorization. Well, I know that 216, well, let's see. I know that 2 times 108 will give me 216. 2 cannot be broken down any further. 108 can be broken down into 2 times 54. Now 54 is going to be 6 times 9. 6 is 2 times 3, and 9 is 3 times 3. So at the end of the day, what I have is, this is the cube root, negative the cube root of, instead of 216, I'm going to write 2 times 2 times 2 times 3 times 3 times 3. Now, you might remember from a previous video that when I had square roots, every time I had a group of 2, one representative comes out. Well, now that I have cube roots, I'm looking for groups of 3. Every time I have a group of 3, one representative comes out. So this group of 3, one representative will come out. This group of 3, one representative will come out. So my final answer for this problem, I'm going to keep writing the negative, and then one representative comes out from that, one from that. This is going to give me negative 6 for my final answer. Let me do one more problem. Let's suppose that I want to simplify the cube root of 16a cubed. The cube root of 16a cubed. Well, 16 breaks down into 4 times 4. Each of those 4s breaks down into 2 times 2. So this is going to be the cube root of 2 times 2 times 2 times 2, and then a cubed is a times a times a. Now remember my rule. My rule is every time I see a group of 3, because I'm dealing with a cube root, one representative comes out. So here's a group of 3 2s, one representative will come out. Here's a group of 3 a's, one representative will come out. So what I have for my final answer for this problem is 2a times the cube root, don't forget to keep writing that, of what's unpaired. Well, a 2 is left over. 2a times the cube root of 2 will be my final answer. This is Cliff Nelson from Redwood Tutoring. Thank you for your time.